Okay, today we're looking at Module 1, continuing with Topic C on unit rates. Lesson 22, getting the job done. Speed, work, and measurement units. Today is like a wedding without the cake and without the DJ. We're going to take two previous topics and we're going to marry them together. I looked at your homework and a lot of you are still not following through on the procedures and the process and the steps used in class, using them for your homework. Make sure you follow the same steps on your homework that we're following in class. All right, so we're going to start off with a really tough question. I know it's Monday morning, but I think we can handle this. Let's get our brains working, jump right into the deep end. How many seconds are in a minute? 60. So how can we verbalize that whole thing as a relationship or a rate or ratio? How can we say that?
There are 60 seconds in each minute.
Okay, 30 seconds in each minute. What else? 60. What did I say?
There are 30 minutes. There are 30 seconds.
Okay, give me another way.
60 seconds
60 seconds
per minute.
per minute. Very good. Verbal cue word. Per. One more.
1 to 60.
Well, we want to keep it in the same order. Seconds per minute.
62.
Mm-hmm.
For every 1 minute is 60 seconds.
For every 60 seconds, there is 1 minute. Very good. More verbal cue words. We also looked last week at how we could write it. We could write it as 60 seconds per minute this way, or we could write it 60 seconds per minute. Those both mean the same thing. And what can we call those since we're down to per minute, per 1 minute, per one? What can we call that? Unit rate, right. Uni meaning one, like a unicorn has one horn. So unit rate. So that's a way of looking at the unit rate. We're going to start with exercise 2. So actually turn your note page over and let's look at page 98. If something is moving at a constant rate of speed for a certain amount of time, so that means if something like a train keeps going the same speed for a certain amount of time, your parents' car probably has something called cruise control. There's a button on the steering wheel where if you press the button, the car will stay at the same speed. You don't have to use the gas pedal. The car will stay at the same speed for a certain amount of time until they turn it off.
Is that like auto driving?
Similar. Cruise control is just for the speed. Okay, they still have to drive. They still have to control the car, but not the gas pedal. So if we know how fast they're going, and if we know how long, then we can figure out how far they went. And there's a formula for that. So with your highlighter, highlight that in your notes. If we know the rate and we know the time, we can find the distance. So distance equals rate. Yes, you do. It's
Page 2.
on the top
Exercise
of
2.
page 98, exercise 2. Okay? Distance equals rate times time. So let's practice it. Chris Johnson ran the 40-yard dash in 4.24 seconds. What is the rate of speed? Round any answer to the nearest hundredth of a second. Okay, so first let's find out what we know. Let's go back and label and identify the information in the question. Let's deconstruct all these words. You ready? So we have here 40-yard dash. Is that my distance? Is that my rate? Or is that my time? 40 yards, my distance, my rate, or my time? Excuse me? That's my distance. I'm going to label that with a D for my distance. Then I have here 4.24 seconds. What is that? My distance, my rate, or my time? That's my time. It's asking me to find the rate of speed. What is the rate of speed? So that's my R. I want to find out what my rate equals. Will this first equation that we found give me the rate? Will that tell me the rate? No, that's for distance. But I can find out the rate with this formula. So you can write that formula down on your note paper. Rate equals d over t. But I don't like that word over. How do you do over? What does that mean? What mathematical operation is over? Not multiplication, division, because a fraction bar means to divide. So this actually means rate equals distance divided by time. Okay, good try. Thank you so much for participating. Distance divided by time. So write that down. Now let's play a matching game. Instead of writing the letters, let's replace the letters with the numbers. So below it, I'm going to do another R equals, because I'm trying to find the rate. What did I say the D was? What did we say it was? 40 yards. And instead of writing the T, I'm going to replace it with the actual time. What is the time?
4.24.
Okay, so that's my rate. 40 yards in 4.24 seconds. But that's actually my ratio. How am I going to get it down to my rate? My unit rate. What am I looking for here? What am I trying to find? How am I going to label my answer? What is it that we're looking for? Forget the operations, forget the steps. What am I trying to find here? I know he went 40 yards in 4-ish seconds. I don't care about 4-ish seconds. What am I trying to find? Not 40 and 4. I want to know
The unit rate?
the unit rate, which is what? How would I label my answer? What am I trying to find?
How many yards in a second?
How many yards in 1 second? So that's exactly what we're trying to find here. So how am I going to do that? What did we say this fraction bar meant? Means to divide. So what am I going to divide over here in my margin? What am I dividing?
40 divided by 44.
Right. Can I have a decimal in my divisor? No. So what do I have to do?
Well, since between the decimals are until it's a non-decimal number,
Until it's a whole number, right?
I think decimal twice, then punch 40 between the decimal twice.
Right. So I have to move it over. So it's 4,000. You can actually use the calculators right now to do the division, making sure your answer is to the nearest hundredth. You're right. Continue.
4.
So you could just read it as digits. 9.43 yards per second. But they only want it to the nearest hundredth. So we look at the third digit, and that tells us how to round the second digit. So it's approximately 9.43 yards per second, because it told us here to just go to the nearest hundredth of a second. Okay? Any questions on where these numbers came? Calculators should be down. We should not be touching them right now. Calculators should be down. We should not be touching them right now. So now we know how fast Chris Johnson runs in 1 second. We found his rate. But now let's keep going. Last week we looked at converting. We converted units of measure using those unit rates. So if this runner keeps up this speed at a constant rate, how many yards would he run in 1 hour? Our answer was in seconds. They want the answer in hours. How fast can he run in an hour? So how am I going to get from 9-ish yards per second to find out how many yards he would run in an hour? I'm going to go meet him at the finish line when he's done. So I'm going to go run for an hour. How far down do I have to go meet him? How far is he going to run in an hour? What do I have to do to convert that 1 second to 1 hour?
I was about 60.
Why?
Because in 60 minutes equals an hour.
Okay, but that's 60 minutes is an hour. I only know how fast for 1 second. You said minutes to hours. How am I going to get to minutes?
Well, if 60 seconds equals 1 minute, then we have to.
So first I have to change the 1 second to 1 minute. Then I have to change the 1 minute to 1 hour. So I'm going to have to do this in 2 steps.
1 times 60 times 60.
Okay, well first, let's hang on to that. I'm going to press pause on you. Let's do that first. You're saying 1 times 60 because there are 60 seconds in an hour. So we're going to set that up, and this is what was missing on a lot of... A minute, yes, that too, both of them. This is what was missing on a lot of your homework. So let's make sure you copy this down correctly. The first thing we're going to write is the rate that we know. We know that he does 9.43 yards per second. So write that first. That's what we know. That's what we know. That's our rate. Now we're going to multiply that by the conversion. What do we know about seconds to minutes? So let's write that. There are 60 seconds in 1 minute. We're writing this in our notes. This is what I should see in your homework tonight. So now we can cross-reduce our seconds. They cancel each other out. So what am I going to see? Yards per minute when I'm done. So then I can multiply 9.43 times 60 and get yards per minute. So when you multiply 565 and 8/10 yards per minute. Instead of saying in 1 minute, if you just want to write slash minute, that's okay. So look at how nicely we set that up. We showed the division. We canceled out the seconds. And so now we found yards per minute. But did that answer the question? No. Now we know the minutes. So now we can convert, I know. Now we're going to go to yards. So we're going to set it up the same way. We know how many yards per minute. So we write the rate down first. Yards per minute. Now we multiply it by the conversion rate. What is the conversion rate?
60 minutes in an hour.
Right, 60 minutes per hour. So we write the second rate there. Yes. It did not specify in the directions whether it had to be in hundredths or not. So we can say 8/10 or 80 hundredths. As long as it doesn't specify. I guess since the part 1 was in hundredths, they kept that in hundredths. So now look, our minutes cancel each other out. So we're going to find how many yards per hour by multiplying that by that. So that's 33,000 948 yards per hour. Per hour. Okay, but like we said before, I wonder instead of doing this in 2 steps, we could just go from seconds to hours. And exactly what you said, we could just all at once, because can I do 2 times 3 times 4? Can I have 3 factors in a multiplication equation?
Okay.
Absolutely. So I can do this 3 and 1. Then I'm going to unpause your question. And here we go. So let's start with the rate that we know about how fast this boy runs. Whoops. So it's 9.43 yards per second. So that's the first one. Oh, thank you. Thank you so much. Then we're multiplying it by 60 seconds per minute, and then multiplying it by 60 minutes per hour. So my seconds cross each other out. My minutes cancel each other out. And then that leaves me with yards per hour. So I'm going to multiply 9.43 times 60 times 60. Those are my 3 factors in my multiplication equation. Fortunately, we already did all the math. So we have our answer again, same thing, 33,948 yards in 1 hour. They were nice enough in your notes and set most of that up for you. And I loved the way some of you matched my highlighting and my crossing out. And that's what I want to see on your homework. That's what I want to see on the quiz. Okay? Questions on where these numbers came from? Why did we set it up that way? All right, let's get one more done before the bell rings. Let's look at number 1 on the next page. Road trip. I drove my car on cruise control. That's what I told you about before, that button on the steering wheel that keeps your car going at that constant rate. Instead of like catching up, slamming on the brakes, and then, my husband's driving makes me nauseous sometimes. So let's highlight the information that we know and label it. 65 miles per hour. Is that distance, rate, or time?
Time.
65 miles per hour. So what do we call that? What have we been working on this for months? Per indicates it's a rate. So that's our rate. Okay? Then we also know 3 hours. That's our distance, rate, or time. What is it? Time. Whoops. Whoops. That's our time. We want to find how far did I go? What does that mean, how far? We're looking for the distance. So we want to know what the distance equals. They gave us the formula, distance equals rate times time. So we bring down the D for distance. We're going to replace the R with the information, 65 miles per hour. There's our rate. Multiply it by the time, T. What is our T? 3. Our hours cancel each other out. So our distance equals what 65 times 3? What? Why did you do it in your head? You had that beautiful margin and a beautiful pencil. That's what the margins are there for. Don't make them feel lonely and useless. It has, what is it? Times 5.